Recording in progress.
Link video.
Hello. Hello, a very good evening everyone to the fourth and the final session of Day 2 of Faculty Development Program. For this session, I would like to introduce Professor K.R. Guru Prasad. He has expertise in robotics, focusing on mechanics and control, motion planning, multi-robot system, cooperative control. He has also worked on the Voronoi partition and its application. His notable work includes presenting research on multi-agent search using sensors with heterogeneous capabilities at the 2008 IISc IBM Operations Research and Data Analytics Workshop. In 2014, along with K. Hungerford and E. Das Gupta, he co-authored a paper on repartitioning algorithm for complete, non-overlapping planar coverage by multiple robots presented at DARS 2014. Sir, kindly come on stage.
Thank you. Thank you for inviting me for this talk. First of all, I will apologize for two reasons. One is I can speak Hindi and understand Hindi, but I am not fluent. So most of my talk will be in. If you want Indian language, I can speak in Kannada, but that you cannot understand. Okay. Second thing is, I am part of IKS team in IIT Kanpur. That is for basically two reasons. One, I have genuine interest, and I work on Indian music. Basically, I am also a musician, of course, to an extent. I play Carnatic classical flute, and I am also a Bharatanatyam artist. So from this perspective, I had been, passionate to look at science of these musical instruments, and that is one of the reason I am also part of IKS team at Kanpur. Okay, so I am also more like you, a student of this rather than actually an expert. Just because I am in IIT Kanpur, they call me as an expert. Okay, let us delve into something. I will focus more on musical instruments, but we will talk about certain other aspects of engineering in ancient scriptures also. Actually, it's a fake window. Window is closed there and somehow it got straight there. Yeah, I am used to certain technology, so I don't know. Okay, so this is a slide which I stole from one of my colleagues. It made sense, and of course I have given credit to him. So I disagree with Western science because science is science. Okay, so whatever we study now in name of modern science is actually Western perspective of that, and for whatever reasons, whatever has developed later in Western sciences. Okay, so I disagree with Western at this point of time, but I just copy from him. Okay, so this is an example. This is actually, so you can see two figures. Of course, it's a joke, so I should not explain it. The number one is called a right angle. Okay, so naturally you will think this is left angle. Okay, but it is still right angle. Okay. And it may not directly make sense, but the idea that we want to take is learn science the Indian way. I think that is what is the attempt of IKS team. That when we were discussing internally also, mathematics, if it is taught from the Indian perspective, the Indians would connect it to in a much better way. So that is it. Okay. I think the PPT is getting stuck there. It is moving there, but it is not moving here. Suppose unshare PPT today, that was. No, there is a lot of 100 conventional solutions. Sorry for the technical glitch, of course, basically, what is mechanical engineering? So when in Indian perspective, things are not compartmentalized. Okay, in fact, even so-called Laukika and Paramarthika are not really compartmentalized, but because one is part of other. So this way of looking at it as a small different discipline is probably not our way of looking at it. And hence we will not really find out explicitly something about mechanical engineering. I could not get that shloka. That is where I actually started with, because when I was Karnam told me to that you have been identified, and Dr. Vanshu called me. So I tried to dig in certain things. So in our mechanical engineering department at IIT Kanpur, our brochure starts with a Sanskrit shloka, which is actually definition of an yantra. Yantra is a machine, okay, and its movement of parts and things like that. And I wanted to put that, for unfortunately I did not have time and I did not get it from the right source, so I did not do that. But otherwise, we may not have something which is explicitly so-called mechanical engineering. Of course, even now, probably the disciplines are going away and we have more of interdisciplinary terms. But one of the foundations of mechanical engineering is mechanics. Okay? So, we are trying to go back to physics rather than engineering at this point of time. Of course, mechanics is common to many other engineering branches. So, the mechanics, we can find out a few things in Vaisheshika Sutras of Kannada. Okay, so there is something called Sanyoga Abhave Grutva Patanam. Okay, I know a little bit of Sanskrit, but not to an extent that I can give you perfect meaning. Abhava means in absence of Sanyoga, something which is holding. Now this looks, though this is attributed to Newton's first law, okay? So in absence of some conjunction, gravity causes fall. So there are two things that we have to observe. One is that quantum gravity is also, because that is one fundamental aspect we deal with in mechanical engineering. We say, Newton invented when apple fell on his head. Okay, so he reinvented. I don't want to get into the logic, ideas behind those things. So, but this is something which is 300, 600 BC. Okay, so that timeline also we have to know. And my perception of, there are different kinds of, scriptures. The main Shastras, Veda and related stuff, including Puranas, according to, my idea, their fundamental this thing is actually moksha. Okay? They are not talking about these things. But you are here, so from here you have to go there. So their fundamental perspective is something else. But there are interpretation of same thing. The purpose is different, but the interpretation can be used for getting the physics out of these things. Okay? The reason I am saying is sometimes in IKS, we had recently a discussion with the head of IKS team. What the IKS team is trying to look at is trying to get information from Indian scripture, which is useful for our day-to-day activities, leaving out the spiritual aspect as a separate thing. So mixing up will actually, spoil things. But in Indian mind, it is not mixing up. They are all part of one bigger thing. So that is where I am trying to say, there is something called Tikupasthana in one of the mantras that I recite every day when I do Sandhya. I was told that the meaning of that is actually salutation to Surya. And I was told, I did not dwell into that deeply, it actually talks about sun is actually the center of the universe and all other things are rotating. But the purpose of this thing is actually goes beyond that material aspect of it. So depending on what is our interest, what I am trying to say is, reason I am stressing this is, when we are trying to look for material science or any other things from Indian scriptures, let us not assume that it stops there. So that is not the purpose of it. So this in some sense is Newton's first law, because unless there is a force, because gravity is a force, things will not move. Okay? And more clearly, Nodana Vishesha Abhava Urdhvam Na Tiryat Gamanam. I can help you split the word. Okay, Nodana Vishesha Abhavat, that is one. Na Urdhvam, no hetu. Na Tiryat Gamanam. Okay. Falling we have already told, because by default there is gravity. So that was the idea here. Okay, so that again means in the absence of any chodhana is excitement. In this context, we have to apply understanding as force. Okay. There is no upward motion, sideward motion. Of course, you can say that there is no motion in general. I mean, they may not be obvious. We have to look into that, and we know something else now because of Newton. Then we will get an idea that they had already known that and they have documented it. Okay. One more thing. So this is more like I would still call it Newton's first law. I will call this more of Newton's first law. This is or in two parts. Okay, with gravity into picture. Nodana Yamishoho karma tat karma karitva cha samskara uttaram tatha uttaram uttaram cha. It looks complicated, so even I may not understand it in the first go. But let us look at this. The initial pressure on the bow leads to arrow's motion. From that, this is basically dynamic systems. How the dynamics of the states of a system, those of you in physics or engineering, you would know. How if I throw the position and velocity of this evolve with the time, it keeps moving because there is an acceleration also, right? So actually it talks about this force causes the arrow's motion, and from that the motion is the momentum, from which the motion that follows the next motion. That is an evolution of the motion that is happening. Okay. Of course, if you ask me more specific question on this, I am not an expert. Okay. I can talk in terms of so-called modern science, but this is actually close to Newton's second law. Okay. Karya Virodhi Karma. Okay. Action is opposed by reaction. This is the famous Newton's third law. Okay. I want you to know the Newton's law of timeline is something like 1686 AD, whereas this is in 600 BC. Okay. So if there are I will not get into that. Whether Newton knew this or not, we do not know. Okay. So for example, like Professor Arna would have talked about calculus. I don't know what exactly he talked about in mathematics. So the calculus people, claim that the Western scientists knew these things. They copied. Okay, so let us not get into that argument. At least we know that all these things, whatever foundations for modern science and engineering is required, that already existed. So it is worth going back to our roots. And actually, sometimes you might get some new idea. Maybe one of us can win Nobel Prize. I mean, just reinventing what we already had. So the idea of the talk is only that. I am not, an expert really to delve into the depth of that and give you the information. So, special thanks to Professor Ishan Sharma, who is my colleague in mechanical engineering, and also he is in space department in Kanpur. And he has given me this much of books, which is not possible for me to go through it immediately. Okay. I am mentioning it for two reasons. One is I got so much of information from him, thanking him, and also there are a lot of such gems in IIT Kanpur who actually on their own they are doing a lot of things. And this is actually, I have given the reference later. This is actually article and book by Professor Kirk, okay, and I have given the reference at the end. And the basic article is available online itself. All these things along with other Vaisheshika Sutras and basically is actually cut and paste from there. Okay. And of course, astronomy is one field where all of you know that there is a lot of work which is done in Indian context, because you want to do any ritual like yajna or whatever it is, time and space is important. Okay, so if you want to do any, I don't want to use word religious, but I am using it in a loose sense. If you want to do any religious ritual, okay, you have to do something called sankalpa. Okay, or sankalpa. So part of that is you have to say which locality you belong and what is the time, that is entire Panchanga, what is this things. Okay, so time and space is important. Being aware of time and space is important, and which space, which time is suitable for what is also is important. That is probably the reason behind so much of expertise that is developed in our Vedika Shastras on this. And one reason I am actually mentioning here, because I was asked to talk on IKS and mechanical engineering, and again it is a mechanics at different level. Okay, so most of these kinds of fields have developed, including metallurgy, material science. Okay, so the metallurgy aspect is kind of, it has been different, but when you talk about material science as a whole, so that also actually, that is where I have told mechanical engineering or mechanical sciences. So I am taking a wider kind of. So there are several things, and sometimes certain things you may not find explicit explanation in any scripture. Even I am taking slightly that path, because in my the main part of my talk, I may not tell you much about taking things directly from scripture. But if you see certain things, for example, even if I am not an architect, even if I cannot find out the Vastu Shastras and things like that and link it to the current science and whatever it is, or go beyond, but just by looking at the architecture, you know that they had that technology. Without that, they cannot actually plan, they cannot execute, they cannot do all those things. These things cannot run on trial and error too much. See, final implementation, the expert, even now that happens. The final engineering is actually kind of expert and trial and error, right? But the main design, the main technology is already available. So that is the way we have to look at. So if you look at this, this one is Professor B. Balasubramaniam. Okay, he has actually done research on the famous iron pillar that is there in the Qutub Minar area. So I got the book, of course borrowed the book, you have to return to me, which is explicitly written by Professor Balasubramaniam on this. He is also from IIT Kanpur Metallurgy department. And I have not gone through the book in detail. I don't know whether the scriptures actually mention, but in spite of that, if you look at that and you analyze that, it doesn't get rusted. That is one of the wonders of life. Okay? And how did they make? What was the material? How did they create the material? How did they design? How did they fabricate? How did they manufacture? Finally, that is mechanical engineering, right? So the science comes from metallurgy. So there is a detailed analysis of that, and that also tells us these people, the ancient Indians, were aware of this thing in a formal way. And the only proof that we get may not getting into this one again, Vaisheshika Sutras. For example, Shraga Sutras also, their purpose is something else. Mathematics is hidden there. So they were not actually talking about mathematics as an independent subject. Mathematics applied, so when you want to do something, you want something, so you just talk about that, right? So it is possible that somebody can delve into the scriptures and try to find out what exactly is written. But at least we have in front of us something which is existing now. We have lost a lot of things, right? So that is one thing. And there was one, big series of books, and this particular series book I have is this thing, okay? And which actually one particular article elaborates on the tool technology and the interactive mechanisms in that book, okay? And I have actually glanced through that. So it again doesn't give you the scriptures directly. It is basically based on archaeological evidence, like based on whatever you get in Harappa kind of sites. You know that wheel was there, and you know that wheel was invented. The Indians were aware of wheels much before so-called invention of wheel happened. Now, what I will do is, this is a topic which is of interest to me because being a musician. And the story goes like I did my master's in IISc, Indian Institute of Science. I worked on robotics. Since I played flute, I somehow knew that C.V. Raman has worked on physics of flute. Since I was playing flute, I got attracted. So I wanted to do PhD in science of flute. Unfortunately, it did not work out. I had to come back to robotics. Okay, but that interest is still alive in me. That is where it is actually a subject which is close to my heart. So one is, music has got a lot of shastras. You have Natya Shastra, you have, of course, a lot of musical stuff is mentioned in Vedas also. So you have Sangeeta Ratnakara, you have the fundamental text, and there are many texts in each region which probably has been written at a much later date. So you have some text, but more than text, you have those ancient instruments which is there in front of you. Okay? And what I am trying to do, that is what I am actually also doing in as a member of IKS team in IIT Kanpur. I am not actually getting directly into the science from ancient perspective, but looking at certain ancient things that are already available from modern scientific perspective. Okay, so what I am trying to do is, so unless they knew these things in some other way, they would not have done that. That is a proof of existence of this kind of knowledge. So that is what I meant here. Let me skip those things. So what is engineering? Finally, you have to understand certain fundamental concepts. We call it science now. Okay? And basically, Vijnana doesn't mean science. So Jnana, Vijnana is, I think, Vishishta Jnana and things like that. Okay? But it's usually translated as science. Fine. So it's again the Jnana was, the knowledge was very fundamental and very important aspect in Indian system. If you know the story of Bhishma, when Bhishma is about to die, okay, Krishna doesn't have any attachment towards anybody. Right? He knows that somebody has to die. And in fact, to Bhagavad Gita mainly says, anybody who is born will die, you don't bother about killing others, in a nutshell. But when Bhishma is about to die, he feels very uncomfortable. And he says along with him the Jnana Parampara is saying. So he says, Brahmaraya and when Pandavas to go sit in front of him and obtain that knowledge. So Jnana or the knowledge or later science or whatever it is has been very core value of Indian tradition system. Okay, so you understand things and then you apply that and create new things. That is what is engineering. Fundamental difference between, of course, now scientists also create new materials. And engineers, we so-called engineers will do a lot of science. So it is not pure in that sense anyway. But science is supposed to be trying to understand the nature, come up with the why this happens. And the engineering is about creating new things out of this knowledge. Okay? So the design, all those things. So if you look at musical instruments, okay, so they are like a device that is there in front of you. You have to understand the fundamental physical principles, apply it and create a musical instrument which can actually do something for you. So that is the idea. So let me start with in any science, we will start with taxonomy or classifications and things like that. There is one of the very important, I might finish within time or I might go. I typically don't have time. So one of the fundamental things you are taught in any subject is classification. There is a for students actually it looks uncomfortable because they have to by heart certain things and write in examination. But idea behind classification is you can study this stuff because they have certain common things in them. You can study this thing. If you study one of something, you can study a lot of things. There are a lot of common things in them, right? Okay. So Natya Shastra says in Adhyaya 28, okay, gives a classification. Tatam cha avanadham cha dhanam sushiram eva cha chaturvidham tu vijneyam atodyam lakshanam vedam. Okay, atodyam. Okay, lakshanam vedam. So basically, tatam, avanadham, dhanam, sushiram. These are four kinds of musical instruments that has been described in Natya Shastra. Okay, tatam, this is a definition. You give a classification, and for each class you give a definition. Okay, that is what is the current way we do in science. So tatam tantri kritam jneyam avanadham tu paushkaram. Tatam tantri kritam jneyam. That is the definition of tatavadya. Basically tantri vadya. Tantri is actually, in Kannada we call it tanti. So it directly comes from that. It's what we call in Hindi, the string. No, string. What you call a string? Nothing close to that. Okay, fine. In Kannada it is called tanti. So it directly almost comes from tantri. And avanadham, okay, we'll come to that, is to paushkaram. Paushkaram is basically, I don't know what exactly is the meaning, but the Adhyaya which talks about that talks about paushkaram. Okay. And dhanam talastu vijneyam. Tala, you know, I mean, for bhajans you do this, right? In Kannada it is called tala, so for me it is natural. Tal, that janjira, yeah, symbol. Okay. Sushiro Vamsha Uchyate. What is Vamsha? Vamsha is also Raghu Vamsha, Hari Vamsha, that is also is Vamsha, that is family, but there is another meaning. What is Vamshi? Bansuri comes from, because in northern India we have this thing where Va becomes Va, like Vanga became Banga and then Bangala, right? So Vamsha, Vamshi is actually, Vamsha is bamboo, Vamshi is made from that, it's a flute. So Vamsha plus Suri is Bansuri, so it is same thing. Okay. So Vamshi is called Bansila, that is what we call here. Sushiro, okay, Vamsha Uchyate. Tatam is a stringed instrument, okay. Avanadham is percussion or diaphragm based instrument, okay. And Ghanam is a solid instrument. So example is Tata. That is one example he gives, and a typical example that gives you a definition. And Sushira is hollow. And I will give an example of Ganavadya which actually might get confused between these two. Okay? But it is a wind instrument. So the typical wind instrument is flute. Of course, we have a lot of Indian instruments. The older instruments are Shahanai, Nagaswara in south, and flute. These are full-fledged musical instruments. Then a lot of these things used during war or in temple. In South Indian temples we use something called, I know only the Kannada versions of that, Kahade, Kumpu and things like that. They have very long district. I have it, okay, Dudumbi kind of. Okay. So those things cannot produce multiple tones and they are not used as a complete musical instrument, but they still produce musical sound. Okay. So I will not get into that. I will not also get into flute. The reason I am not getting into flute is flute as it is a similar version exists in West also. So I don't want to argue which came first and things like that. Okay. I will try to cover the first two aspects, Tatam and Avanadham. And then it's show an example of Ghanam. If you want to discuss anything else within my knowledge, we can discuss later. Okay. Fine. So this is, I don't want to get into Veena or Sitar. Okay. tambura is what we call in Kannada. Tambura or tamburi is what we call in Kannada. And I don't know whether it is really true or it is basically come from tam bruhi. Tam, it actually tells him. Because music is also not entertainment in Indian context. Its a fundamental purpose is actually towards moksha. Okay? It tells about him. That is the idea. I mean, Shruti, this thing is very important aspect of any deeper spiritual sadhana. So the tambura is the what is called it is called in Mahani. So this is actually a overall picture. I thought I can write on the board. That is why I did not a lot of things here, but I'll explain it in case you will understand. So, how many of you have seen tambura from close? How many? Okay. There is something called, I don't know what it is called in North Indian context. I don't know whether the word jivala is South Indian or it is universal. You know, jivala means it is actually life. Jiva is life, right? So, jivala, if it is I don't know if it is a Kannada word or a South Indian word. Okay. So, this string is not some random stuff which somebody does. So anybody who knows can tell me what it does? It's the reason I brought it because veena and tambura basic constructions is same, and sitar is slightly a different version of that. With physics and all those things, it is actually similar. Okay, and veena as it is actually mentioned in all scriptures, including this thing. Sitar is a modern avatar of that, so that is where I am not actually bringing it. In veena kind of instruments, what happens is the frets come into picture. Okay, so they are also not copied from West, and that's a very interesting thing. I might touch upon that with the flute and this thing if you have time. We will not touch it now. We will come back to it later if we have time. All of you know basic physics, right? Somewhere you have studied. This is string vibrates between two fixed ends. Okay, this end is almost fixed because this is sharp, right? So typically this side, if you see guitar or any other instrument, I think this will not be like this. I don't remember, I cannot visualize how it is now. Okay. This has got this special curve, this thing. And particularly Hindustani musicians, because I know one of my friend in IIT Madras who is a guitarist. Okay. So they are very particular about getting it manufactured by some expert in Kolkata because they will do those rich things. But from basic physics perspective, it is vibration of strings between two fixed points. Okay. Two fixed point, there is what happens, what is the fundamental natural frequency, there is a standing wave pattern. All of you might have studied in some distance, right? So the first one is, this is actually quarter of the wave, accordingly the what is the corresponding frequency is determined. So the frequency of that is determined by several things. One is the tension in the string, length, and of course the material properties indirectly come into picture. So the density basically comes into picture. So you have that. So tension you actually typically adjust once for all, ideally. When it goes out of tune, you will do that. Okay. Then when you pluck, what happens is actually you excite the natural frequency of that. Natural frequency of that can be found out by this standing wave pattern. The first wave is like this, second is like this. So it is called node and antinode. These two are nodes always because it is so, we call it boundary condition in this thing. So boundary condition is that it cannot move because it is fixed. Alright? So that is the area. Now you get musical sound out of it because if first frequency is say n hertz, okay, then you have 2n, 4n or 3n, 4n, so on, the multiples of that, then they match. For example, those of you who know music, if I say sing sa and the upper sa, they match the frequency because second one is exactly double the frequency of this. If I sing sa and somebody else sings re, it sounds awkward together. Because beats come into picture and things like that. Okay, so one important thing in physics, indirectly mechanical engineering, is that if a sound has to be music, there is a difference between sound and a musical note. So musical note has to, if you look at the spectrum of that, it should contain the so-called harmonics of the fundamental frequency. If it is not harmonic, then it will not sound like a musical note. Okay? So if you found dholak kind of instrument, they cannot be tuned. Okay? So they are not competing with the main frequencies, that is why they don't disturb. Okay, most of the drums, I will come to that, they do not produce so-called musical tone. Okay? So first of all, your musical instrument should give you the musical tone. The strings have that property inherently. So that is where string is a natural thing. Now, what happens when you actually, I had a tambura and I had experimented with that, so after coming to know, I did it more carefully. Okay. Nowadays, unfortunately, at least in South Indian, Carnatic musicians use that electronic tambura, and now even not that, I have app in my mobile, I don't care about tambura. But these physical things are important because they have a different vibrations. They have it is not just about the sound you generate, the source of sound and also things become important. Okay, so anybody can tell you, I think.
We just played like tambura when some music was going on.
No, what? How do you adjust the thread?
With that factory.
No, thread. This thread.
There's something which is pulled and then madam will just do that for us.
You just play once, move it. At some point, you will get reverberating sound.
Yes. I don't know if you said this.
Okay? And it might look random, but C.V. Raman worked on that. Okay? So, I am not really an expert. Professor Anurag Gupta and Professor Pankaj Chhatrapati have worked on these things in IIT Kanpur. Okay? I know at the first level, basically that is, mechanics is not my area at the professional level, so I don't get into that. But what is happening is, I told you about boundary conditions. Other side is fixed boundary condition. Here there is a floating boundary condition because this is actually like this. This is actually like this. So at this point I have my string. That dampens oscillation, so oscillation cannot go here. Then your string, it is instead of vibrating, when it comes like this, boundary condition of the length is changing. Equivalent length is changing. It's actually not vibrating at one point. I mean, board would have been helpful, but see, if you have a wedge like this, if there is a string passing, it has to vibrate as this fixed point. Now you have this, and your string is actually going like this. When it comes down, it gives you asymmetry. When it is going up, the length is more. When it is coming down, length is less. Okay. And C.V. Raman has done experiment, and Professor Anurag Gupta and Pankaj Chhatrapati have even attended one of his students' talk. They have analyzed because C.V. Raman's times numerical analysis and computer simulations were not that popular. Now we can do because these are continuous distributed systems, more difficult to analyze. Okay, so you can mathematically look at them. Now you can analyze. To even analyze, you have to become at that level, right? So do you think they would have randomly got this? So that is the way I am trying to say. They were aware of that. It is not just by luck they got something. Okay, so that is what I wanted to tell in context of tambura, a special aspect that is available only in Indian instruments. Okay, then of course there is acoustic design, there are various things. The shape is not only for acoustic, it is for aesthetics, it is for spiritual reason, then it is also for acoustic reason. Okay, that is what I wanted to tell you here. Now before I go on, the concept of Saptaswaras are there in Natya Shastra, and I do not know how. The concept of notes are exactly same except for the subtle difference, because we have concept of Shruti, where my base frequency is, I can choose anything. After that, remaining things will be relative to this. If I want to sing sa as 100 hertz, my next sa is 200 hertz. In between, you have to divide all these things. Okay, the simple so-called equally tempered scale will come to 12th root of 2. Between two, there are 12 notes in between. Out of the 12 notes, there are, even in West, only 7 notes are given names. Right? A, B, C, D, E, F, G, that's all. We have Sarigama Padani. Okay? They are seen. So, fundamentally we have that, we did not borrow from them. That is what I wanted to tell you. And in Carnatic music, from based on Natya Shastra, we have much more intricacies than slightly in the way we name. For example, we have 3 reeds, we have 3 gas, and we have 3 gas, and we have 3 knees. Okay? But they are still 12 notes. I will not get into that. Okay? So the way we get into the notes and also things, they are explained in Natya Shastra. They are given all these names and everything is there. Okay? And whatever is a current adaptation, that might be give and take from everything. And to standardize, we use their Shruti concept. I say I sing in A sharp or B or C or whatever it is. We have that freedom, but we will still standardize so that, but when two Indian instrument, if I have an accompaniment of tabla or mridanga and violin is directly not Indian. Current version of violin is not Indian, but people say that was a Dhanurveena, which was the previous avatar. It went there and came back. That is a different thing. But of course, we have sarangi, which is purely Indian, this kind of that. And there is a veena kind of instrument with a bow. I don't know what it is called. No. Boy. Veena looking instrument with bow. I have seen this video. I don't remember what that. Okay. So the bowing was not also foreign to us. So if you have Indian instruments, they are continuously tunable, including flute. Whereas Western instruments are standardized. The reason they are so much standardized because they have A, B, C, D. They are singing based on that, not they are based on my Shahuji concept. Okay. So that is it. Okay. So this is about Veena, the Tata family of instruments. Other details I am skipping. Okay. Where you have to keep frets and also things, lot of physics is into that, because you want to have the note, you have to have the fundamental frequency which should be matched with the corresponding length. It is not a trivial thing. Final execution by the manufacturers, there is a trial and error and his experience. But overall design is still there. Each one of them is not doing a random trial and error, even now. Then let us get into there is a beautiful book by Australian called Fletcher. When I started this work, I saw he has done a lot of work. Okay. And all sorts of instruments, and he has got, there are a lot of Westerners among Indians, old ones. Currently many people might be working, but only I am aware of Sri Rama and several people. But in Western this thing, they have taken music as a serious engineering business. Okay, so I have a book of him. In fact, when I started my PhD, I wrote to him. He was very old by that time. He posted his paper, physical papers from there to India. Okay, I really appreciate him. I am not making. He actually has got a complete book on physics of musical instruments, all categories. And I told you about this, right? I forgot to tell you this. This classification is very scientific. The mechanics of sound production in all string instruments, including violin, is similar. There are distinctions, obviously. In all Avanadha Vadyas, they have this vibrating diaphragm. If you want to, in a textbook, in Fletcher's textbook, this chapter has to be like this. Okay? Then Ghanavadya, solid instruments. Then you have wind instruments. So this classification is, even from modern perspective, is scientific. So that is what was done, in our traditional literature, because they were aware of this. And in fact, we have a lot of this thing. Classification is a one very standard practice in. Okay, so he classifies these things into two groups. One is something which makes a strong sense of pitch, and some things which do not. Okay, and for sake of completeness, I have given a Western instrument also called kettle drums. Even I was not aware of what it is till yesterday. Okay, then he said tabla. This mushroom mridanga which became like this. Now I don't know what happened. Okay, so most of other instruments do not produce musical sound. Okay. Because they are at very low frequency, they do not produce complete your musical notes, so it doesn't sound like noise. That is, basically, if it is not musical sound, it should be ideally noise. So that is a very. So mode of vibration of an ideal membrane is not harmonic. So mode of vibration of an ideal string is harmonic naturally. But whereas a diaphragm, if you tie a diaphragm, so we have instruments like kanjira in Carnatic classical music, where it is more like we do not really have an equivalent of that in North India. I have not seen that. But there are larger instruments like where you have a ring and you have a stretched diaphragm. But in South India we have a small this thing, and that is a mainstream percussion instrument called kanjira. Okay, so those things are not really musical. It is, if you do ask, experts in mechanics like my colleagues, you do the analysis, and vibrating member, the modes of vibrations are not harmonic. The first mode to next mode is not double the frequency. So that is what it means. If it is not, it will sound like mixture of many notes. That is a problem. Okay. See, unlike vibrating ring, string, or half column, that is. Flute also, naturally it is harmonic. Kettle drums are supposed to produce approximately harmonic sound. I have a picture of that and I will show you why. So this is modes of vibration of standard stretched this thing. You can see the frequency. This is fundamental frequency is 1. The next mode is 1.594. Next one is 2.136. Don't worry about the shapes. Okay, it's actually, if you look at the vibration modes, for example, in a string it is one dimensional, so it is easy. It is this and it is this. If I have a diaphragm, it is, the mode is nothing but the first mode is basically circular mode where entire surrounding is node and entire thing goes up and down. Now what happens is one side goes up, another side comes down like a sine wave. So that is what it actually means. There are different modes. You can observe that this ratio is not harmonic. That is what I wanted to bring. Right? So any mechanics fellow, and this is basically physics, but mechanical engineers use it more. So vibration of diaphragm cannot produce musical sound. This is a so-called kettle drum. Any physics enthusiast here can tell me why it might give you musical sound? This cavity has got a natural frequency. Okay, so this fellow modes of vibrations are actually not the ones which produce the sound that we hear. The sound we hear are because of the air inside we vibrates. So that has got a natural harmonic kind of behavior because it becomes more like an instrument. That is why this produces. The diaphragm is simple. Okay. The mridanga and tabla, what happens? Again, you know that mridanga, which is also called mardala, I think in Odissi dance it is mardala, that is more close to mridanga. And the tabla is later invention based on mridanga. So fundamental physics remains same. There will be, of course, lot of differences because it is played and all such things. I am not getting into the subtle things. So that is the reason I am actually focusing on Mridanga. And Mridanga is a word which you find in all our scriptures. Okay, Nandi plays Mridanga and a lot of things. Okay, and the couch is also, Shankha is also one such things. I have seen something on net. Okay, but we being scientists, we don't want to borrow from there without actually verifying. So I was told that the pattern of certain vibrations, if you see their shape, visualized shape, they look like Shankha. Anyway, Shankha is also a wind instrument because it is hollow. It's basically a wind instrument but produces only one note and musical note. Anyway, and that is not made by man, so let us not look at it that way. Okay? Mridanga, of course, all of you have heard tabla also. Before they play tabla, they have to tune. They cannot randomly start. If it is any other percussion instrument, they need not tune it. Okay, that you find out in bhajans and things like that, people who put, and you have this northeastern version of, what is it that is called? I know it, but I'm not dole. Kung or dole. I think it is called dole. It is called dole. That is made up of mud, but still the same structure. That also produces a clear-cut musical in this thing. Now, if somebody is playing that, those of you who have musical sense, if somebody is playing that in one shruti and you are singing in some other shruti, you will not be able to hear. Whereas a dholak kind of person can accompany anybody, right? Because that is not in the musical range. This has to be tuned, and they can produce, in fact, notes also, sa and re at least prominently they can produce in Mridanga, okay, or in tabla also. In tabla, the left also has got some similar thing, but it doesn't really produce strictly the tonic kind of this thing because it's again low frequency. But the right, both in Mridanga and tabla, they produce harmonic sound, but it is still mechanics wise it is a vibrating diaphragm. Okay, vibrating diaphragm has got a uniform density. When you have uniform density, it cannot produce. If the density is variable radially, you manipulate it such a way that it can now produce, because the density is not uniform. In your string, density was uniform. Fortunately, it naturally produced the harmonic pulse. Whereas in Mridanga, it is artificially made. Okay? So, all of you know that black thing, it is called different things in different regions. I think it is called Shahi here, right? Yeah. So this Mridanga appears in all scriptures, and there is a chapter on Mridanga in or Bhoshkaravadhyas in Nateshastra. And it produces tonal musical tone in spite of being a vibrating diaphragm. So you can see this, or you can see this. Okay. So they have a hollow structure. Though this is hollow, it only aids in acoustics. Why don't you call this Sushira Vadhya? It is hollow. But mechanics of sound, the sound is produced not because of that, it is produced because of this. So that is where you have to observe that scientific classification. Right? It is still hollow. Yeah, that way tambura, all instruments are wind instruments. Why? Acoustics, finally you have to hear sound. Sound actually travels in air, and even my vocal cord is a wind instrument. Okay? It's not wind, it's actually string instruments, and the wind generates that string motion. Okay? So you have this construction, and the way it is constructed, it is truly specific to this thing, and also any mridanga or any tabla cannot be tuned to anything. Like in principle, sitar or veena, you can keep tightening it and produce note. But if you keep tightening it, it will break. Right? So that range is there. Similarly here also, of course it is not a ductile material like these things. So you cannot keep pulling the leather. Right? So there is a limit to which you can do. Okay, overtones are tuned harmonically by loading the drum head with a paste of starch, gum, iron oxide, charcoal and other material. Lot of material, this thing comes into picture, Okay, you can always argue that somebody, randomly was doing something happened. But that is just for that, logically saying. Even when you randomly do it, if has to be repeatable, first time it is possible that somebody did randomly and he did that. But if you want to do it second time, you have to, at least they would have understood later. Whether invention itself was random, it doesn't matter, right? So I am talking about not from the scriptures, I am talking from, I was told there are a lot of, I did not get that reference. There is not Natya Shastra, there is another scripture from where they have given the construction of musical instruments. Okay, that I wanted to get, but I was not able to do that. So this is you can see this, these are the mode shapes. You actually put certain iron powder kind of thing and excite. Okay, the vibration modes will be wherever there is no vibration, all these things will go and settle. They actually tell you where the nodes are of the mode shapes. So these are different modes, and this is, I took it from Fletcher's book. Fletcher has taken it from C.V. Raman's. I have C.V. Raman's paper, but I had to dig into that. Okay, this is done carefully. A typical diaphragm cannot produce this thing when the density is uniform. You make the density non-uniform in a specific way so that now it can produce a harmonic sound. Okay, these two are really wonders. That Jivada business, the way you design this thing, the pitch and this one. So that is where I wanted to specifically mention. And this is engineering to me, and it is dealing with physical vibrations, so it is mechanical engineering. That is what I am trying to do. These are the notes. Now you can see 1, 2, 3, 4, 5. This is a fundamental frequency. Next mode is harmonic. Next mode is harmonic. Next mode is harmonic. Harmonic. Whereas compare it with this fellow. I hope you are able to see that. If this frequency is 1, it is not 2. This is 1.594 from random frequency. And what happens when you actually excite thing? Typically, only one mode will not be excited. Simultaneously, many modes will be excited. So it is equivalent of I am playing different notes simultaneously. Will it sound musical? No. If I say sa, pa and sa together, it will sound musical. If I even sing sa and small re together, it will actually give you this. Right? Of course, there are a lot of things like you have chords in Western system, we have called Vadi and Samvadi Swaras where they actually match with the things. Okay, so this is the construction, this is the mode shape, and this is the fabrication method, which is traditional, not scientific in the way we look at it nowadays. Okay, and they have knowledge which is transferred over generations. Okay. And in fact, the Varna system in Indian system is actually coming from that professional aspect. Okay, there is a Vaidya. His son easy for him to become Vaidya because he has got that exposure from at the home itself. Okay, that is where the profession was linked to so-called now what we call caste. Okay, so because it is natural for them to have. So there are bad institutions, there were those things, but home is also a part of schooling. So that is where this the son will observe and those kind of things. So that is where things become. So this was we had an internship project on this from IKS. So one of my students actually compiled this material and did that. So this is the one, and then they will put the so-called, this is the exploded view of this. And this is basically, this they keep changing, and all musicians are aware of that. This they will remove, they will reput. Not every day. Okay. In addition, on the left side of Mridanga, okay, they put some switching kind of thing, mix it with, make some duff kind of thing, and basically that will make it heavy and produces more bass sound. That is not done in tabla because tabla the left also has got something which is fixed. Okay. So this is Dhanavadya. I put this at the end. Suddenly I remember this also is interesting instrument which is only in Indian things. This is hollow instrument. Why it is Dhanavadya not Sushira? The sound is generated by the solid part of it. The inner part will actually amplify it and it acts as basically sound box. Of course, this is played only typically in Carnatic music. So they use the top also to give special effect. But the fundamental this is not normal madka. It has got iron powder and I don't know. There are things so that it is actually tuned for a specific listening. Okay. So this is two materials. This one of these things, okay, is available. If you just put this thing, you will get a document. Okay, I have downloaded that. Not downloaded. It's basically directly an HTML file kind of thing. So all others, these two are actually what I presented in the beginning. Okay, and then other things I have just given. So Professor Amita Ghosh, also senior professor in IIT Kanpur in mechanical engineering. I was not aware of he was interested in this because I never had a intersection. And this is actually Professor Bala. This is from IIT Kanpur. This is Professor Balasubramaniam I mentioned about the. Okay. And there are many such books. Some of the books that I have actually got from Professor Ishan Sharma is what I have. And C.V. Raman's paper on Indian musical instruments. He has worked on mridanga, tambura, itara, and violin. Okay. And I was saying he left food for me, but I meant to work on that. And physics of musical instrument book by Fletcher and this thing. So that is what is the. I have taken only the Indian aspect from that book. Okay. And that's it from me. And we can talk on food, we can talk on many other things within my limitations. And thank you very much. And in sitar and veena, sitar it is more prominent. The first level of producing note is actually changing the length. Second is changing the tension. Yes. That is where you give gama. Yes. That is where you give gama. Yes. And violin, that is not possible. So it's a continuous instrument. There is something called Chhatrapati, which looks exactly like tambura. See, veena and South Indian tambura are same, except for you have frets, other fancy details. There is no this thing, so it is actually they have something and they will slide. Yeah. It is not like this Mohan veena kind of. Sarangi also is a kind of. Sarangi, I say, is a modern existing violin, Indian version of violin, so that is mechanics wise. Physics behind. So there are a lot of other details. I don't want to generalize it too much. Any questions? Any interactions? Any other questions from anybody?
We feel so proud that we were so good and everything like comes. It seems like everything is coming from the best, but everything has gone from here.
Yeah, I mean. Thanks for this opportunity. Till now in IKS I was only worrying about looking at our instruments from modern perspective. I interacted with Ishan Sharma and I went to his office. I looked at so many books that the kind of work it actually motivated me. Hopefully I will continue that and do something. Because I have working knowledge of Sanskrit which I can in principle improve. This was on music, so if you are at least interested in music, it would have been interesting. But there it is, beyond IKS and beyond the engineering aspect, science aspect. Okay?
I wanted to ask this one general question regarding the methodology of IKS.
Huh?
Methodology of IKS.
Methodology?
Indian knowledge system. So if I want to understand Indian knowledge system, when you
I
say
don't want to comment because I am not that structurally working on IKS. So I can give you certain tips from my side that it is read lot of books written by a few of them I have shown. There are well-known IKS scholars. Okay, so get an idea about how do you go about. Then be very careful because I'll tell you one thing. The Indian knowledge system, I have actually mentioned that earlier. Okay, this is close to my heart and some of you may not agree with that. So there are different layers. If there is some shloka in Veda which you can decipher and say that it actually talks about distance from earth to sun was this, it is correct, but that is not purpose of that shloka. So don't stop there. Or if you want to stop there, it is fine. Don't say that is all the meaning of that. So that way we are not doing justice to IKS, we are actually bringing it down to modern science. And we cannot help but look in West to kind of get the certification. But sometimes we have to go beyond that. The idea behind IKS is actually studying Indian knowledge system which comes from not only from scriptures, from the practices, from the way the farmers traditionally way they actually do things, because everything is not tangible or not written, right? There are a lot of whatever I have told you now. Some of them is there in Natya Shastra or some other book, some of them in practice. So those things we have to observe and convert it into such a knowledge system which can be taught or used like we use the modern science. And this will not compete with modern science because science is science. Okay, the philosophy of science could be different, but science, there is a truth, the material truth, fine, it's material truth. There is a material truth, so it doesn't, which is not restricted to anybody. So that is what is the idea behind IKS as far as I understand. Because I cannot give you more detailed account because I am not really authorized. We had an interaction with Professor Kanpur recently in this thing because they are the person who know basically what is the intention of the entire structure. Thank you.
thank you, Professor Prasad, for this enlightening talk. Thank you for all the faculty members and participants who have joined us. Students, I know this is too many things to process, but it is something that you can get started with. We really want you to work on these things and explore your ideas in this and beyond this also. There are snacks for all of you outside.